Good afternoon, students. Today's experiment is FM modulation and demodulation. So as you please recall that in our last experiment, which was experiment 5, we learned about FM modulation and demodulation using MATLAB simulation, right? So it is the same experiment, but this time we are going to perform it using the hardware. So as usual, here you can see we have a power supply. So we have power supply here, AC to DC power supply, and it generates outputs of plus 15, minus 15 and 0 volts, right? So using these plugs, connect this power supply to the signal generator. So this signal generator basically it generates the modulating signal or the information signal, which in this case is 300 Hertz, and the level is 20 volts peak to peak. So peak voltage is 10 volts and peak to peak is 20 volts. So it's a sine wave. Modulating signal is a sine wave generated by this module called function generator. All right, so 20 volt peak to peak, and the frequency of modulating signal is 300 Hertz. Yeah, so modulating signal is basically a sine wave of frequency 300 Hertz and peak to peak value of 20 volts or peak value of 10 volts, right? Next is the FM modulator. So this is called FM modulator. It is now currently operating, it generates the carrier frequency of 20 kilohertz. We can change this carrier frequency, but we are for the sake of this experiment we are using a carrier frequency of 20 kilohertz, right? So baseband signal had a frequency of 300 hertz, carrier frequency has a frequency of 20 kilohertz, and here we have selected FM, right? Now we have a FM modulator here. So the input of the FM modulator is the output of function generator, which is a baseband signal of 300 Hertz. Input is 300 Hertz, 10 volt sinusoidal signal. And the modulator, it receives two inputs. One is the modulating signal and the other one is the carrier frequency, which is 20 Hertz, 20 kilohertz. The output is a modulated signal, we get it here. Now we use this interface called sensor chassis to display our signals on the computer. Okay, so this is channel A. We are using it to display the baseband signal, information signal, and channel B, blue one, we are using it to display the modulated signal. All right, so if you move to the computer screen, so here you can see the red curve is the baseband signal or modulating signal having a frequency of 300 Hertz, and you can see that the peak voltage is 10 volts and peak to peak voltage is 20 volts. That is, this is what we have set on the panel. And then this blue curve is an FM signal, right? So 20 kilohertz carrier modulated by this 300 Hertz information signal makes a carrier, makes a modulated signal, right? So blue curve is a modulated signal. Okay, now if I click, so this is time domain plot of both modulating and modulated signal, which is FM signal. Okay, so this is frequency domain. So these are frequency domain curves of modulating and modulated signal, right? So you can see that the modulating signal, the red curve, is 300 Hertz signal, right? So this scale here is in kilohertz. So from the frequency axis range is from 0 to 30 kilohertz. So this is 10 kilohertz, this is 1 kilohertz, and then this is about 300 hertz. So you see, so amplitude spectrum of modulating signal, red curve 300 at 300 hertz. Now FM signal, modulated signal, right? So we have the bandwidth of FM is infinite, but here we are not seeing other peaks, right? So frequency modulated signal, amplitude spectrum of frequency modulated signal, you have centered at 20 kilohertz, 20 plus 0.3 kilohertz, which is 300 hertz. Yeah, so 20 point, you are seeing peaks at 20.3 and 19.7 kilohertz, right? So recall that the FM signal has frequencies which are placed at FC plus FM, FC plus 2 FM, FC plus 3 FM, similarly FC minus FM, FC minus 2 FM, FC minus 3 FM, etc. But here we only see FC plus FM, which is 20.3 kilohertz, and FC minus FM, which is 19.7 kilohertz. We don't see the other peaks at higher frequencies. All right. And now we want to demodulate the FM signal. So we have added another module here, which is FM demodulator, right? So the output, the modulated signal, this one, out of the FM modulator, we are now supplying it at the input of FM demodulator, and the same carrier of 20 kilohertz we are generating in the FM demodulator, which is supplied to the demodulator here internally, and then the output of demodulator, this is the output of demodulator, pass through the filter, and at the output of filter it is tapped and it is given to the input B of the interface sensor chassis, which is called sensor chassis. So the output A is the original modulating signal, and output B is the recovered signal or demodulated signal, right? So it should be the same signal. So what we'll do is, here in time domain, you can see that the red curve is the original modulating signal, yeah, and blue curve is the recovered signal, demodulated signal. So they have some time phase shift, but in shape they are essentially the same, right? So shape is the same, time period is the same. So let us see what we have in frequency domain, right? So in frequency domain, you can see that both the red curve and blue curve, they overlap, and the frequency is 300 hertz. So frequency spectrum shows that both the signals, the modulating signal and the recovered signal, they have the same frequency. So we have successfully recovered the information signal using an FM demodulator. Okay, so this was today's experiment, and it was about FM modulation and demodulation. All right.